welcome. My name is Ryan, and I work at a little company called Pixite, where we make creative consumer apps. If you know me from Twitter, then you most likely, better than me, know my son, Milo, who's somewhere in the back. So feel free to say hi to him somewhere, unless he's napping. Cool. So today I'm going to talk about doing some server development in Kotlin, more specifically with a library from JetBrains called Ktor. And so what is Ktor? So the tagline on the website for Ktor reads, easy to use, fun, and asynchronous. So what is Ktor? I like to think of Ktor as a library that lets you build composable DSL-based web services in Kotlin. So before we get into some code, and this talk is going to be a lot of code, we're going to go step by step building a project that I've been working on. But before we get to that, I want to talk a bit about how Ktor works, specifically about its composability. So the main actor in a Ktor application or server is the application object. All right? This is what accepts requests from the servlet engines and returns responses. When you build a Ktor web app, you first set up the engines. And Ktor applications have interchangeable engines and servlet drivers that allow them to work with several different servlet engines. The standard servlet driver allows it to work with auto-scaling environments like Google's App Engine. In addition to these drivers, you can create a Ktor application by installing features that add functionality to the server. And this adds functionality like routing, serialization, HTML templates, static content, authentication, and much more. Many of these features are built in, but you can also get them from external dependencies by adding simple Gradle dependencies, or you can even create your own custom features. So now I want to talk a bit about this project that I've been working on, and it is a server project. So you're in the right talk. So I've been working on this server project that I chose to use Ktor for pretty early in Ktor's development. Just so that you know, Ktor is almost released. It's 0.9.5 right now. And one of the big reasons for that is that it's largely based on coroutines. And so we need coroutines to come out of experimental before Ktor can be publicly released. So this server project that I'm working on is meant to work with an app, right? I have an app, and we sell in-app subscriptions. Now, according to Google's documentation, when you work with subscriptions or in-app purchases or anything like that, you're supposed to verify that purchase against your own server. That way, if somebody has a pirated version of the Play Store or some other way that they can circumvent actually paying for your in-app purchases, you verify on the server an environment that you control to make sure this is a valid purchase. Now, what the server is going to do is reach out to the Play Store APIs via the web, and it's going to make sure that there's a valid transaction in the Play Store API that matches up with the purchase information you got on the device. Now, the last piece that I needed in my system was a web interface for administering this. So I want to be able to have a web console where I can manage or cancel subscriptions, all of that sort of thing. The main point of this is verification of purchases. But the other nice thing about this is that it easily allows you to adapt to a subscription sharing model. So in my app, Pigment, it's a coloring book. A lot of people like to color on their iPad, right, their tablet. But maybe for their phone, they have an Android device. If they subscribe to premium content on the iPad, on the phone, they should also have that premium content. And so a system like this will allow us to simply add some sort of user identifier. And now when a user logs into the app, we can see, do they have a subscription not only on the Android device, but on any device? So that's the system overall. Now let's get into some code. So here is one of the most basic servers that you can write using Ktor. So to look at this, we have that application that I mentioned, and we actually make an extension function on the application. There's a configuration file that you deploy, or configuration depending on if you're running locally in development or on an app server. It's really simple, and just for simplicity's sake, I'm going to keep it out of this talk. We're just going to be looking at code. But that configuration is what points the Ktor server at the particular extension function you want to use. So after that extension function, we have routing, and this is a feature that we're installing. This is some shorthand, but this is the main container for your code. So we're going to make a post route at the verify path, and that post route right now is simply going to return hello world. So let's run this and see what happens. We're going to use curl. Since we're using a post route, we can't just use the browser because that only does get requests. So we're going to use curl to make a post request with some empty data, and we get back hello world. And hooray, we've made in 5 lines of code our first Ktor server. So to make this useful, though, we need to do more than serve static responses. And what we really want to do for a JSON API is return typed responses. So that everything's type safe, we'll return typed responses. What we want to do, going back to the server code, is be able to have a response object, whatever that might be for a certain API call. In this case, it's a simple response object that has a status that's a string. And you can see I updated the server up there to respond with that response object. This is ideally what we want. So let's see what happens. We plug that in, we run it again with curl, and nothing. We get back nothing. We could play around with running curl in verbose mode and figure things out. But wouldn't it be nice if the server would just tell us what went wrong? So here's where we get to Ktor's composable functionality. What we do in order to get this type of information back is install a feature called status pages. And this is the standard feature installation notation. So status pages is a built-in feature. And what it is it's a way that you can catch exceptions. In this case, we're going to configure it to catch the throwable, which is just any exception that might be thrown. And you can have it respond however you want. In this case, we're going to respond with just the text, the message of the error, and a response code internal server error. You can set up status pages so that there are different responses for internal server errors or authentication errors, anything like that, and return whatever you want. And we'll see a bit later on how easy this makes the rest of our code. So now that we got this feature installed, we still have a very simple web server here. We run the request again using curl, and we get a message back, can't transform this request content to response. So now we know what's happening. The server doesn't know how to translate that response data class that we gave it into anything. So let's go back, and we're going to collapse the status pages to make things a little easier to read. And as you might imagine, we're going to install another feature. And this feature is called content negotiation. Now this is nothing new that JetBrains or Ktor invented. Content negotiation is the standard mechanism by which a server and a client negotiate to determine what type of content they're going to communicate with. And you'll recognize this with different HTTP headers like content type and accepts. So when a client sends a request, there will be an accepts header. And that'll tell the server what type of data, what MIME types that client can accept. And then when the server responds with data, there will be a content type header, which will say this data has the content type application JSON or text plain, whatever that might be. So we do a little configuration here, and what I like to use for JSON, I'm an Android developer, I should mention, is I like to use a library called Moshi. Some friends at Square created this library, and it does a really good job, especially with Kotlin, to serialize JSON in a type-safe way. So what we're going to do to enable that is simply add the JSON class annotation and tell Moshi that at compile time, I want to generate an adapter. And this is all, if you don't use Moshi, if you use JSON or Jackson or something else, then it's all the same. You can simply add JSON or Jackson converters just like this. So now here's our simple server. So let's run this again and see what happens. So now we run our request, our post request to our server, and we get back JSON, just like we wanted. What we gave the server was an object, an instance of an object, and we got back this JSON. So perfect, that's exactly what we wanted. And again, here's how simple this server really is. So we're just going to collapse that so we can move on. And so that was about sending typed data in the response. But this is a JSON API, so we also want to get type-safe data out of the request. So let's take a look at typed requests. So if you remember, what we're doing here is we're verifying in-app purchases from a device. So what data do we need? Here's the documentation from the Google Play API, the developer API. This is how you connect to the developer console. And in order to get subscriptions, which is specifically what I work with, we need a package name, a subscription ID, and a token. And this is when you make a purchase, what you get on the device. So that's pretty simple. Let's just create a request object that contains those fields. As I mentioned before, I also want to be able to share subscriptions, so I'm adding in a user ID, which in this case is an arbitrary string. If the user doesn't log in, it could be a Firebase authentication token from an anonymous user, or really anything else that will uniquely identify that user across platforms. So we need to update the post route here. So to do that, we're going to take that request. And the way that we do that is with this call object. So you'll notice that a lot of this in Ktor looks like a DSL. And that's exactly what it is. It's a DSL to make your web services. And this inside your route is a route object. And what you have on there is a call. And this call is a wrapper for the request, the response, the environment of the application, and a few other items that sort of travel throughout the pipeline as a request flows through the system. On that call object, you can receive items out of the request, and by using those brackets, we make this a typed request, and we tell it that the type that we're expecting is request. Now, if the request can't be deserialized, if Moshi can't make a request object out of this, this is going to throw an exception, which immediately you might think this is bad. But if you remember, earlier we set up status pages, and so the server is automatically going to handle that exception and return an internal server error with the message of that exception. In development, that's exactly what we want. We want to share the internals of our system. In production, we might change that to be a generic, something went wrong, we'll look into it message. Once we have that request, for now, we're going to use that call object again to simply respond with that same object, just so that we can go one piece at a time. So this is our server, pretty simple. Before we run this, we need some JSON, and so I'm just going to put some JSON in a file. This is what it looks like. You can see we have a user ID, package name, product ID, and token. And this is actual data from my app, Pigment. So this is going to be a valid response. So now we make a new curl request. We have to send the content type, and that's what tells the server that, hey, I am sending you JSON data. We use the D parameter to point it at that file, send it to the server, and we get back that data. This looks super simple, right? The server's just responding with whatever it gets. But if you think about what's happening here, the server got the data, it deserialized it automatically by me just calling this call.receive method. The server took care of deserializing it based on what the client told it it was, and it gave us an actual object. We returned the object, and the server took care of converting that to JSON for the client. So this is fun, but not super useful. So let's build it up some more. So what we need to do is take that request and do something with it. And that brings us to using Ktor with external components. And I'll show you in just a minute what I mean by external components. But first, let's talk about what we need to do. So we get the request object out of the server request, and we need to find a valid subscription either cached in the database, or we need to look for it remotely on the Play Store's API. If we find it remotely but it wasn't cached, we're going to cache it locally. And then we simply return that subscription we found, or we return a 404 saying we couldn't find a valid subscription based on this information you gave us. So what are these external components? Well, we have an API. This is going to be the Play Store API. In the library that I'm working on, this is actually extended a bit. So this is a generic interface, and my version of this will connect to the Play Store API, the Apple App Store, the Amazon App Store, the Unity Store. It'll connect to all of that and try to find an appropriate purchase wherever it can. That's how we do the shared subscriptions. Now, I wasn't going to do this until, I don't know, yesterday afternoon, but I realized that all of the code in these slides is so close to a fully working example that I wanted to share with you the code for my Play Store. So if you want to download these slides and take them and making a working verification example, you can do that. So here we've got the Android publisher that we create lazily. The code for that is in the Getting Started guide on the Play Store API documentation, so I didn't include it. And all we do here is create a request to the publisher API. We give it that information. It gives us back a response. We convert it to a subscription. Now, if you look at this, what you'll notice from all of the coroutine talks that you've been going to over the last day and a half, that we're using coroutines here. As I mentioned before, Ktor is an asynchronous server, and it's all based on coroutines. Initially, I thought, why is that important? It's sort of a serial thing, right? A user makes a request, and then they get a response, and they're used to waiting for that. It's not a big deal. But what this does is allow Ktor as a server to be extremely performant. Because every request that comes in, if we have to make a request to the API, this external system, which is going to take n number of seconds, we don't know how many, we don't want that server to stop waiting for this request before it can go to another request, or to have to use a separate thread for every single request that comes in. So by using coroutines, we can spread out that load. While this request is being made to the server, other requests can be handled on this thread, and it allows us to use the efficiency of coroutines, which is sort of a lightweight threading model, as I'm sure you've learned, on the server, so that instead of having to scale this server up and add 10 servers to handle 100,000 users, we can hopefully use 3 or 4 servers. So anyway, that is our API. The other external service we talked to is a database. I'm not going to go through implementation here. There's examples to work with using JDBC, H2, different server drivers. I actually use the App Engine data store in mine because I run my app in App Engine. But this is pretty standard. There's a few methods to get subscriptions out of the database and one to save subscriptions to the database. And you'll notice all of these are suspending functions. We do the same thing with coroutines. So how do we use this in our app? That's really up to you. For this example, I'm going to just make some local variables that are, a totally real API and an in-memory database. And you can serve these from shared resources, from singletons, from using dependency injection, however you want to get them. It doesn't really matter at the end of the day. And then we're simply going to use this in our request. So we try to find a subscription in the database. If it doesn't exist, we try to get one from the API. If we get one from the API, we save it to the database. And that helps us not bypass the Google Play Store's, 100,000 requests a day limit. They ask you to cache these for at least 24 hours. And then for this last part, if the subscription is null, we return not found, which is a 404 with a message, subscription invalid. And if we found it, we simply return the subscription. So let's take a look at that. We're going to use some valid JSON. This is the same JSON that I used before. So it has the user ID, the package name, subscription ID, and token. And when I submit that request, you'll see I get different data back because the server, the Play Store API, gives us a little more information. And this is one of the main drivers for this as a project for me, because you'll notice one of the pieces of information you get here is the expiration date of a subscription. So Google, quick sidebar, Google has this requirement that since they don't prorate refunds, if somebody cancels a subscription, you have to serve to the end of the subscription. But they also don't tell you on device when the end of the subscription is. You might think that's simple. I'll just, if it's a monthly subscription, I'll do it to the end of, a month after their last renewal. But you also don't know, are they in a trial? Are they in a promotional period or any of that? So this web API allows us to understand when the expiration date is. Have they canceled, but they're still in that? When did they actually start everything? All of that. So back to the talk. If we try this out with some invalid JSON, this is, I think for this JSON file, I simply added a character to the token to make it an invalid token. You can see we get back that message, subscription invalid, and that's a 404, which curl will not show you. So that's it. So we have a REST API here. It has one post request, but more can easily be added. So let's move on to that admin interface, because this is something that we're all going to need in our web services to make them easy. This is our web server right now. Let's collapse that down, make things a little easier to read. What I want to do for an admin interface is I want to be able to see a list of all of the subscriptions, right? So I'll have a GET request at the subscriptions URL, and you might think we've already done something like this. I'll just get all the subscriptions out of the database and simply return them. So if we do that, what happens when we run it in the browser is we get the JSON data, because all we've told the server is how to convert objects into JSON. So that's what we get at this point, and that's correct but not super useful. So let's go back and take a look at how we can change this. As you might imagine, we install a feature. In this case, we're going to use FreeMarker. FreeMarker, the Apache FreeMarker template language, is a well-known Java templating language. And we'll configure it to pull our templates out of the resources directory in our project. So that's pretty standard configuration stuff there. And then what we need to do is update our response here. So all we do is we set FreeMarker content there. We give it the subscriptions and a map of data, and then we tell it which template to pull from. So you can see, super easy. Let's look at the template. Real simple, right? So we're going to go through this line by line, and eventually we'll have a working system. That's not true. All of this is just standard HTML. So we're going to ignore most of this and just look at this part. This is FreeMarker templating. You can find more information at the FreeMarker template website. This isn't a FreeMarker template talk, but just to point out, we passed in subscriptions. We can iterate over that here, make a row in our table for every subscription, and we use the mustache, $ mustache, to pull out the data of each subscription into a cell. It's pretty simple. So let's go back to the browser and refresh that and see what we get. There we go. We have a full template. So this is all driven by the server, and aside from some standard HTML, it was a couple of added lines of code. But now we have a problem. You can see how all of the problems sort of build up like a snowball, where the whole world can see our entire list of subscriptions. So we want to add some authentication. So going back to our server, can anybody guess how we add authentication? Yeah, we install a feature. I take it I'm getting repetitive. Exactly. So we install a feature, and it's called Authentication, as you might guess. And built in, Ktor has a whole bunch of different authentication mechanisms. Because I'm lazy, I'm going to use basic authentication, which I'm sure you all know is extremely secure and a great way to secure everything. Basic authentication just means I don't have to make forms and that kind of stuff. But Ktor does support out-of-the-box form authentication, basic, bearer authentication, I think, OAuth, all sorts of things. They have a real long document if you want to integrate with Google's OAuth that even tells you how to set up OAuth from Google's side, which seems to change every other week. But so anyway, we make a basic authentication type, and you notice we give it a name, which seems a little weird. But I didn't really understand when I just started with Ktor, why would we give a name to our authentication mechanism? And the point is you can have different routes that have different authentication requirements that maybe authenticate against different systems, or maybe authenticate as an admin user versus as a regular user. You need to use some different authentication. So we're going to set this up. Realm, it's part of basic authentication, has to do with what's put in the headers. The value's not super important for a project that's not even written in an IDE, but written in Keynote. And most of these authentication mechanisms have this validate block, where you're given credentials. The credentials are different based on what type of authentication. For basic authentication, you get a name and a password, and you do with it whatever you want. In our case, I typed auth service, which just returns some static values for this case. But basically, you do whatever you want with these values. And the idea with this validate block is if you return a value, then that means authentication succeeded. If you return null, authentication failed, and the server, using your status pages that you installed before, will handle that accordingly. What you return is pretty close to not at all important from the respective Ktor. There's an empty interface called principal, which you just put on any object you want, and that becomes the object you can return from here. And then you can pull that out later, and that means that you can store, if you have multiple tokens, or if you have a user object that's backed by different things or composed differently, Ktor doesn't care. So let's collapse this and look at how we use it in the routes. And Ktor decided to make this really difficult. All you do is you wrap the route in an authentication block, and we're done. This is now an authenticated route. We added here the name of the authentication we want to use. If you only have one type of authentication, omit that, and you're fine. But we do want to use that data, right? I mentioned that there's a user object in here. So again, very simply, we're going to just expand that out so we can look at it. And then we'll just get that user out of the call object. The call object, if you use authentication, will have an authentication object property on it from which you can get the principal. And this principal is whatever you returned from the authenticate block. So in my case, it's a user that has, I think it has a username, a password, and like a first name field or something. Not super important. And then we're just going to add that to our template. And then we go back to the browser, refresh the page, and we're presented with the login dialog. And this is how Chrome handles basic authentication. It's standardized. This is why I did it, because it's easy. So we type in some credentials there, we hit sign in, and we're logged in, and you can see up there in the top right that it now knows my name because I gave it a user object. So that's it, right? We have this admin dashboard that doesn't really do anything. It shows us stuff, but the last thing that I want to talk about is forms. Just to give an example of how to make things more interactive. On the web, if you're not using Ajax, which I'm not in this case because I want to keep it simple, I'm going to use simple forms. So let's take a look at what we want here. This is what we have right now. We have a list of subscriptions, but I want to manage those subscriptions. So I'll update it here, and you'll notice that I added these buttons over on the side. And these buttons are just going to allow me to cancel or delete subscriptions. So pretty simple. You might think of a few ways to implement that. I'm going to do it with forms, in which case I'll show you each one of those buttons is going to be a form in and of itself. So to do that, we're going to add a route under our authentication. It's going to be a post route, and we're going to receive parameters. So when you submit a form, you have parameters, just like in a get URL, you have the name equals value, and the same thing in a form, only that's in the post body. So we get those parameters. This parameter is effectively a map. It's a map of lists of strings with some added functionality to make it easier to query. So what we do is I'm going to get the ID of the subscription out of the parameters. And if that doesn't exist, since this is a required parameter, I'm going to throw an illegal argument exception. Again, I'm throwing exceptions into the wild here, but we have that status pages set up. So if we get an illegal argument exception on an HTML request, Our status pages are set up to know how to handle that and tell the user gracefully what went wrong, right? So we'll do the same thing for the action. This is going to be delete or cancel. And then pretty standard Kotlin code. We act on the action. If it's delete, we delete that item from the database. If it's canceled, we get the item out of the database. And then we put the subscription back in the database, but we do it updated, so with a canceled flag. And then we simply respond with a redirect back to the list of subscriptions. To update the templates, again, standard HTML, but we're going to be using some FTL tags, the free marker template language tags. We make a couple forms. It's pretty simple. It's a post request to the subscriptions action. We have some hidden inputs for the ID, and this is what's going to get submitted with the form, and a button that submits it. And then now you can see we click cancel on that subscription, and the page is going to refresh. And it was very small, but what you could see there is that the canceled status on that user was changed to yes, and the button to cancel is disabled because we redirected to that list with our updated data. So that, in a nutshell, is a fully working Ktor system that we did in a little over 30 minutes. I have plans to open source the system if you want to be doing in-app purchase validation in any of your systems. That'll be coming later this fall, as all software release promises go. But if you want to learn more and if you want to take a look at Ktor, you can do that on the web, ktor.io. GitHub, this is all done in the open on GitHub, Ktor.io, Ktor. The Slack channel is reasonably active in that you'll get responses if you want them. The Kotlin Lang Slack, there's a Ktor channel. If you want to talk to me, I'm easiest to reach on Twitter at rharter. And if you want the slides, you can get them at ryans.link/Ktor. And with that, I would like to thank all of you for coming to learn why servers hurt Kotlin.